In the winter of 2020, 2 Detroit police officers arrived at Robert Williams' home in Michigan. Without any explanation, they handcuffed him on his front lawn while his whole family was watching.
He pulled up. He said, "Are you Robert Williams?" I said, "Yes, I am." He said, "You're under arrest." I said, "Whoa, what am I under arrest for?" He said, "Don't worry about it," and proceeded to put the handcuffs on me.
Detectives said he was arrested for federal larceny. The proof? Images captured by a surveillance camera and analyzed by a computer algorithm.
He showed me a picture. He said, "So that's not you?" I said, "No, that's not me." Turned over another paper and said, "So I guess the computer got it wrong."
The computer got it wrong. As in faulty facial recognition technology wrongfully identified Williams as the culprit.
And there had been others who had been arrested by that same police department. And part of this is these are the stories we know about. Because in some ways, the AI systems are acting as silent witnesses with flaws.
Right. That's Dr. Joy Buolamwini, computer scientist, poet, and national best-selling author of the book Unmasking AI. I'm an AI optimist, but if we're not mitigating its pitfalls, we'll never see its full potential. Which is why in this episode, we're taking algorithmic bias head-on. Why does algorithmic bias happen, and how can we avoid it? I'm Rana El-Kalyoubi, and this is Pioneers of AI, a podcast taking you behind the scenes of the AI revolution. Dr. Joy is one of the leading experts on algorithmic bias, a hero of mine, someone who, like me, is a big believer in AI and a staunch advocate for how we can make it better. But our conversation didn't start there. It started with us talking about what inspired us to get into tech in the first place. Early on, I guess, you met the MIT robot Kismet, which for our listeners who are not familiar with Kismet is a, gizmo-looking robot with like blue eyes and furry eyebrows, very 90s style. But I don't know if you know that, but Kismet inspired my own research because it was the very first social robot that had social and emotional intelligence. And so I've really looked at Kismet as an inspiration for a lot of my work. But how did you meet Kismet?
Okay, I think we were similarly inspired. So when I was little, I had a very strict diet. And by diet, I mean media diet. So I could only watch PBS.
Love that. I should have done that with my kids.
It's a different time. You know, we were immigrants. My parents weren't exactly sure what else was on TV. So PBS seemed safe. So I would watch Nova, Scientific American Frontiers, all of this. So I was watching one of these shows and they had an episode about robots. And I remember seeing at that time graduate student Cynthia Brazil, and she was the one who had created Kismet, the social robot.
If we want to build a robot that can interact with people, communicate with people, and learn from people, it has to also be social. Because that's the way that people are going to try to teach it and the way they're going to try to communicate to it.
And like what you were saying, I hadn't seen a robot that was actually developed to interact with humans. And so the big expressive eyes and the ears and all of that, I was so captivated and I was curious if I could make something like that. And so from then on, I said I wanted to be a robotics engineer and go to MIT. I didn't know there were requirements.
I love that.
But I saw that and I wanted to be a part of it. And I think also seeing that it was a woman behind it as well. I didn't even question it. It was just like, oh yeah, this is of course something I could do.
Growing up, I had a similar experience. My mom was one of the first female computer programmers in the Middle East, and she paved the way for me and so many other women. For Dr. Joy, her childhood dreams of going to MIT would come true. She would even end up working with the same code used to program Kismet. But her first stop was Georgia Tech, where she was admitted as an undergraduate in computer science.
When I was working on one of my first robots, Simon, I was at the time trying to get a robot to play a turn-taking game with me called Peekaboo, right? Peekaboo, you cover the eyes, you uncover the eyes, peekaboo, I see you. Peekaboo doesn't really work if your robot doesn't see you.
Right.
And my robot wasn't seeing me. And so that's when I really started thinking, okay, what's going on the computer vision side? Because it was detecting the face of my roommate who was fair-skinned, green eyes, red hair, not necessarily detecting me. But I got somebody else to do the demo and I, kept going.
This was Dr. Joy's first experience of being unseen by a robot. And she let it slide. But the second time came a few years later in graduate school at MIT. This time it was too blatant of a mistake to ignore.
I had taken this course, Science Fabrication, and I wanted to explore the concept of shape-shifting. Again, I mentioned we had 6 weeks, so I was, all right, not changing any laws of physics anytime soon. So maybe instead of shifting my physical appearance, maybe I could somehow alter my appearance in a mirror. And so I worked on this project called the Aspire Mirror, and I found this material, half-silvered glass, which essentially has a really cool property. If you have something black behind it, it behaves just like a regular mirror. But if there's light behind it, the light will shine through. So I thought, if I put a black background and then add a digital mask, then it would make it seem as though that mask were on my face.
Okay.
And so this is all digital first, right? And it worked. I was like, okay, this is so cool. But now let me see if that filter can follow me.
Great.
Right. So I needed to get a webcam, and then on the webcam, hooked it up to my laptop. Now I needed some face tracking software to achieve the effect. So nothing to do with social justice or anything like this.
You just wanted some facial recognition technology to just track your face, basically.
Yeah, so I could have this cool Aspire Mirror thing. And so I wanted to look like a lion or look like Serena Williams, now maybe Roger Federer, just whoever, right? And so when I was trying to get that to work, that's when I noticed it wasn't really picking up my face consistently. So I draw a face on my palm. Hold it up to the camera. It was not the best face. It was very much the smiley face sort of thing. And the face on my palm was detected. So after that, I was like, okay, anything is up for grabs.
It was around Halloween at the time, and Dr. Joy had a white plastic mask by her desk, the kind you find at the drugstore. As an experiment, she reached out and put it on.
It's not even halfway on my face before it starts being detected. I take it off, my face is not detected. I'm just like,
what is
you
going on?
Can't even make this up.
What was your first thought? Did you think it was a bug in the system? Were you angry? What was the emotion?
Well, I mean, people with dark skin have been seeing the limitations of cameras for a while, right? So before we even get to computer vision, if you're thinking film, the early film, the way the chemical solutions were created, they were optimized to expose lighter skin. So if you see photos from back in the day, right, you might just see dark-skinned people and you see the eye whites and maybe the teeth. And those are actually design decisions. It didn't have to be that way. And in fact, I remember reading about the Oprah Winfrey show actually getting specific cameras from Philips. I think they were LDK series that had microchips that were optimized to actually show darker skin better. So that's okay, these are design decisions. And then Kodak changed their film when chocolate companies and furniture companies were complaining, you can't see the fine grain of my mahogany. Some of us got a Winfield. Now they're marketing it so good it can shoot a black horse at night. If it can shoot a black horse at night, it might be able to show my... So in some ways, it wasn't so surprising that in the world of vision, right, that there are these issues. But what I was surprised about was I had all the lights on. That's when I was like, I think there might be something more here. So it was I was curious, and then it also did make me think of the book is called Black Skin, White Mask from Fanon.
That's Frantz Fanon, the political philosopher.
Where he was talking about the ways in which people of color have to mask who they are in order to be rendered visible or seen by society as well. So it almost seemed too literal. I was like, I can't make this up.
Yeah.
So I responded with curiosity. Why is this happening? Is it because of this specific environment, or is there a broader pattern here? So it really became that launching point for exploring more about computer vision, but also AI more broadly. Like, what else could be going wrong?
The programs that power facial recognition are built by people, which means they are built with the same biases, unconscious or otherwise, that are already baked into society. Technology is meant to be the great equalizer, bringing access and opportunity to everyone. But if the computer systems we build can't even see us, we're just reproducing the same inequities that already exist. As a computer scientist, Dr. Joy wanted to get to the root of this coded bias. How is this happening, and how widespread was it?
Our human fingerprints are all over AI and automated systems. So this is engineer hat comes on.
Yep.
What's going on? Let's debug it. Let's figure out what's happening. And so this led down a whole exploration where I started looking at a little bit of how we even train machines to detect human faces. And so it turned out they were using this concept of machine learning, right? So let's provide a data set of examples of faces and use that as a way of training an AI system to detect a human face. So I started looking at those data sets, and I started looking at the most popular data sets, and I started saying, I think I'm seeing where the problem is coming from. So I would look at a gold standard benchmark, right? This is the one we're using to judge progress in the field. Over 70% male, 80% lighter-skinned individuals. And then I would look and I was like, oh, and they're taking it from images of public figures.
Right.
And oftentimes politicians. So I was starting to see what I was calling power shadows. So you have the power shadow of the patriarchy, right? When you look at women's representation when it comes to political positions, you tend to be in the 30% or less zone. So that men were showing up 70% or more in these data sets wasn't too surprising once you start considering the source. Similarly, when you're looking at the prevalence of lighter-skinned individuals, even though the majority of people on Earth would be classified as people of color, who's more likely to have their photos available online? And then there was another technical piece about it. So for computer scientists to collect large sets of data, we ain't got time and we're lazy. So what we're going to usually do is run some kind of automated system.
To scrape data off the internet, basically, right?
Absolutely. And so to get face data sets, people would create face detectors. That way you're not scraping every image, just the image that has a face, but a face that has been detected. So I also found out that the face detectors themselves were especially more likely to fail on darker skinned faces. And then, scientists had, okay, let's run an experiment. 1 of 1 is not enough to make a generalized conclusion.
Right.
So that's what led to my research.
Again, I think that's a very important concept. The training data is really important, and it's not just the quantity of the data, but the diversity of the examples you're using in the training data set, whatever problem you're solving with machine learning. But it's also the validation. It's what we're testing on, right?
Absolutely.
Because if it's not representative of humanity and people who are going to be using the system, it's going to end up being biased. At Affectiva, the company I started around emotion recognition, early on, we also kind of faced this idea of data and algorithmic bias. We did a lot of work in China, and we were recognizing people's facial expressions and smiles. And we got a call from one of our biggest clients in China, and they were like, this technology doesn't work. Like, you're not detecting any smiles across our Chinese kind of customers or users. And we looked at it, and we basically realized that we didn't have enough representation of Chinese population. But also, we were putting everybody in the same bucket, right? Like as we were testing these algorithms, we weren't really paying attention to subpopulations.
Absolutely. I used to talk about so much of this data being pale male data, and that's destined to fail the rest of the world. So there's an undersampled majority that was implicit in some of these data sets that I was seeing. And I started to think, what does this mean outside of the face arena?
Dr. Joy coined the term coded gaze. It's her way of describing algorithmic bias, and it's based on feminist theory.
The male gaze is this concept of who is prioritized and whose perspective influences the choices of what we see in visual representation. And so when it comes to, let's say, art, and they talk about the male gaze in art, you would look at how women were being posed as objects of desire for a male viewer. Also, if you're thinking about the white gaze as well, Toni Morrison used to talk about this in relation to her writing, where if you're writing a book for a particular audience and you're talking about a Russian, no one's saying, well, no one's going to relate to the Russian character because of this, that, or the other. You're seeing the universal humanity of that person. Yet if you're talking about somebody who was having an African-American experience, suddenly you're getting all of these questions about, well, what about the perspective of this white person? And so pointing out the fact that some groups were so used to being centered that when they were no longer centered, it felt destabilizing, but that itself was showing the white gaze and this expectation of whose perspective matters or should be prioritized or even what is considered worthy.
I'm seeing this in AI all over the place, right? Like we need more diversity of people who are building different AI technologies, but also solving different sets of problems.
I agree with that. But the other part to add some nuance to the conversation that I realized was it's important to have diverse people and diverse perspectives. But I was the Black computer scientist who built the Aspire mirror that did not detect my face.
Right.
And so there it's looking at the people involved, but looking at the processes. So in this case, what was I doing? Okay, I need a system that can track my face. GitHub. So I go online, I go to an open source place to see if I can find some pre-existing code. So just like if you're building, I don't know, you have a backyard fence project, you're not going to go chop all the wood. You go to Lowe's, and you get the pre-made parts. So I was also saying, what are some of the pre-made parts that we use and what's baked into that? Because if you change the people, but you don't change the processes, you're still going to be able to perpetuate that kind of discrimination. So I was realizing we had to go back to the roots even more. So the process and the people are both important.
In a research project, Dr. Joy set out to quantify how accurate facial recognition technology actually was. To do this, she created her own data set of over 1,000 diverse faces. Her plan was simple. Process this data through facial recognition technology that some of the biggest tech companies were making and see how well they did. But to test these companies, she first needed to figure out how to classify her data. She tried to organize the data by race, but that got messy pretty quick.
I never felt race was more constructed than when I'm going through ethnic enumeration across different countries, across different times, even looking at the U.S. Census, the way labels changed, right, over time. Talking to my Egyptian friends, and they're like, so do we put African American?
Exactly.
Do we put white? But some of the justifications for doing ethnic enumeration in different countries is supposed to be around discrimination. But we know Arab Americans get discriminated against in all kinds of ways where that's not even coming through. And then I learned there are all kinds of whites, so looking at ethnic enumeration in European countries and also specific moves that were made to kind of paper over ethnic distinctions, right? And in efforts to have a sense of national unity. And so when I was going through all of this, I was like, all right, let's move away from race. Let's move away from ethnicity and let's look at skin response. A close to objective, right.
She decided to classify the data using the Fitzpatrick scale, a classification of skin pigmentation based on reaction to UV exposure. Then, she used her data to evaluate how accurate facial recognition technologies really were. But so then you basically find that all the Face ID systems out there, especially those kind of published by the big tech companies, were biased.
More or less. So I was specifically looking at gender classification and binary gender classification. So I didn't test every kind of task they could have done. So whether it's, is there a face, right? Face detection. I was in the Wakanda era of what kind of face, you know? And so for gender classification, I did open source systems for my master's work, as well as systems from IBM, from Microsoft, from Face++, which was a company based in China that had access to over 1 billion face photos. So I wanted to know if this data part mattered, or was it the type of data? So I included them there. And then later on, we included Amazon and Kairos. What we found was for gender classification, binary gender classification, here's a photo, guess male or female. All of the systems perform better on male-labeled faces than female-labeled faces. They all perform better on lighter-labeled faces and darker-labeled faces. But then this is where it got even more interesting, just like you were saying with your own work with affectiva, the subpopulations matter. So if we had stopped the story there, it's okay, we have this gender bias, we have the skin type bias, but then we did an intersectional analysis. So I wanted to see if there were differences between lighter females, lighter males, darker females, darker males, and they were, and the stories weren't all the same. The story that was consistent is they all did the worst on darker females, but some actually performed better on darker males overall, right? And the differences between lighter females also changed. And so part of that exploration was saying you can't just assume the trend is going to be the same. You can have a hunch, you can have an intuition. As scientists, we have to test this. And also as product leaders, we have to test this before we put it out, because we can't just assume if we're using these universal benchmarks that aren't representative of the rest of the world, that aggregate score is A-OK.
Exactly. You got to look at the details. Dr. Joy published her findings in a study called Gender Shades. She sent the results to the 3 companies she audited: Microsoft, IBM, and Face++.
IBM got back to us almost immediately.
Amazing.
And actually invited me to their headquarters to meet with their teams behind the systems. And they had a new model, and I actually tested that model. So when I presented the official results of the paper at the first FACT conference, Fairness, Accountability, Transparency, the timing really worked out for me that there was actually a place to even publish
That's awesome.
this kind of research. When I shared it, I was able to say, here's where they were then, and here's where they are now.
That's awesome.
You know, but something that struck me was shortly after, there was a report, I think, from The Intercept that said that IBM had been working with the New York Police Department and actually creating tools that would help them search surveillance videos to search people by their hair color, by if they had facial hair and other things. Basically digital profiling enabled by computer vision. And so there was a part of me that's like, okay, it's good that these companies are paying attention and understanding that there are these accuracy gaps, accuracy disparities, but accurate systems can be abused.
Right.
And so in some ways, because I started this kind of research in such a surveillance adjacent or surveillance heavy space, I really had to grapple with those questions immediately. And then I'm thinking, okay, if we have accurate facial recognition, think about drones with cameras, with guns, right? Mistaking civilians for combatants is problematic, but also if you got political enemies, right, that can be abused in other kinds of ways as well.
Remember Robert Williams, who we met at the top of the show, the man who was wrongfully arrested because of faulty facial recognition? She actually presented his story to President Biden and other elected officials during a roundtable discussion about AI. When Williams was arrested in 2020, the story made headlines, but it didn't make change.
Here's the thing. 3 years later, Portia Woodruff was wrongfully accused by an algorithm. Same police department, faulty facial recognition.
Oh, wow.
She was 8 months pregnant. She was being accused
Wow.
of a carjacking. I don't know I haven't been 8 months pregnant, but I assume it might be hard to jack a car.
Right.
Context
Right.
clues, people, context clues. And there had been others who had been arrested by that same police department. And part of this is these are the stories we know about. Because in some ways, the AI systems are acting as silent witnesses with flaws. Right. So these have real world consequences on people's lives.
And as AI continues to become more and more mainstream, we're kind of encoding these biases in these everyday decisions, right?
Yeah. And it could be, it might not be, are you getting arrested? It might be, are you getting the job?
Right.
Because you have the bias in the resume screening systems, or do you get fired, or hired, and things of that nature.
So you founded the Algorithmic Justice League, and I kind of sometimes picture you parachuting into these companies with a cape. So what do you actually do, and what are the sort of campaigns or policy work that you take?
Yeah, so a big part of our work is raising awareness about AI harms and ways to prevent AI harms. And I think now that more people are understanding AI's impact in society, there's even more of an appetite for it. In the early days, if I would mention something like algorithmic bias or AI discrimination, it's like, okay, what are you on about?
Right.
Now it's like, and of course we will be addressing the algorithmic bias. So the discourse has changed since 2016 until now. So that has been good to see, but they're also evolving harms and evolving threats. So I think sometimes it's easy to think, okay, we know about this problem, but you're not looking at the ways in which it's evolving. Another big part of what we do is we fill this gap we were seeing when we did an ecosystem analysis, which is, where do you go if you've been harmed by an AI system?
Right.
The research is necessary. The white papers are great. If I've been hurt, where do I go? And so we actually started building this thing called the X-Coded Experiences platform. And so around that, we do different campaigns. One of our recent ones has been for writers. So as a new author, I was like, wait, what are they doing with the text? How are they training these systems? And so this is a campaign for creative rights, about the 4 C's. There should be consent. There should be compensation. There should be credit. There should be control. We also do campaigns around biometrics. So one of the latest ones is actually looking at the introduction of facial recognition into airports. Many people don't know that at the TSA checkpoint, this is supposed to be optional. We've been documenting the signage covered in a different language, turned over, the smallest print you ever did see. I mean, light blue on dark blue. I don't know. It's not giving visible to me.
There's no explicit consent, right? And people don't have the opportunity to opt in and out.
Exactly. So you have that coercive consent kind of thing. So those are some of the campaigns that we do where people can know their rights, know if there's a right to refusal. We do creative science communication. So like the film Coded Bias, some of the poetry that I do. And then we also advise decision makers who want to know what can we do to prevent AI harm. So for example, in the book, in the epilogue, I talk about the roundtable I had with President Biden and Governor Newsom, whose hair is as perfect in person as it looks on TV, verified.
I think a lot of people want to do the right thing. They just don't know how to. And so providing a roadmap on how to mitigate these kinds of biases is really powerful. What are some of the applications of AI that you're most excited about?
My dad's a professor of medicinal chemistry, pharmaceutical sciences. So his life's work has been devoted to drug development. And he was working on computer-aided drug design using neural nets when I was a little kid. So I would go to his office. He would have these huge silicon graphics machines, and you could see different proteins and their shapes and all of that. And I didn't know much about it other than my dad does cool stuff to help people, And so when I saw AlphaFold come out and the progress that's been made there in terms of basically characterizing all known proteins and their shape, this is huge in terms of what it can enable for scientific breakthroughs, for future therapies and all of
that.
Drug
discovery, accelerating scientific discovery. That is awesome.
Very excited about what that can do for humanity, for sure.
The intersection of AI and biology and how it's accelerating and really revolutionizing medicine and health is really powerful.
But I also do have a bit of a cautionary tale there. I was thinking about one organization called Melologic. The founder, Avery Smith, his wife died due to melanoma. And when they first, noticed something was wrong, it was stage 4. It was really late. And I learned that people with darker skin tend to have melanoma diagnosed much later on.
Okay.
And there are 2 parts to it. One are the stories we hear, right? I'm like, oh, I'm dark skinned, I'm protected, I'm good. But in this case, right, you had studies coming out from Stanford saying, oh, AI systems are performing better, right, when it comes to detecting melanoma and so forth. And then you look at those data sets, and like the face data sets, data sets for dermatology were also heavily skewed. And so it's like, okay, AI can be a tool here, but we have to be very intentional about being inclusive.
Yeah, we have to do it right. So we've mentioned several times that Dr. Joy is a poet. And in my experience, to move hearts and minds, you need more than just the data. You need stories, emotions, and a reason to care. Listening to Dr. Joy's poetry, I feel hopeful that we have the power to shape the future by putting humans at the center of AI.
I usually try to choose a poem that's based on the kind of conversation we had or the theme of the podcast. So in this case, I'm going to choose one called Unstable Desire.
All right.
Prompted to competition, where be the guardrails now? Threat in sight will might make right. Hallucinations taken as prophecy. Destabilized on a middling journey to outpace, to open chase, to claim supremacy, to reign indefinitely. Haste and pace control-altering deletion. Unstable desire remains undefeated. The fate of AI, still uncompleted. Responding with fear, responsible AI beware. Prophets do snare, people still dare to believe our humanity is more than neural nets and transformations of collected muses, more than data and errata, more than transactional diffusions. Are we not transcendent beings bound in transient forms? Can this power be guided with care, augmenting delight alongside economic destitution? Temporary band-aids cannot hold the wind when the task ahead is to transform the atmosphere of innovation. The android dreams entice, the nightmare schemes of vice. Poet of code, certified human-made.
Thank you for joining us today, Dr. Joy. This was wonderful.
Thank you so much for having me.
You can join the conversation on LinkedIn, Instagram, TikTok, YouTube, and X. Just search for @Pioneers of AI. Thanks so much for listening.